Hi, in this video, I'm going to go over system of equations that you would find on the SAT. Now, in this one, we get two equations there. It says in a given system of equations, k is a constant. If the system has no solution, what is the value of k? Okay, so k is our constant, meaning that x and y are variables. We have two lines. We can tell these are two lines because the x's and y's are to the first power. And when we have two lines, we have three possible scenarios. It could be that they have one solution, they meet at one spot, okay? Or they have no solution, where they don't intersect at all, or we have infinite number of solutions because they're the same line on top of each other. In this first scenario, with one solution, the two lines need to have different slopes. Second scenario here, they have the same slope, different y-intercept. In the third scenario, the same line, so they have the same slope and same y-intercept. So here, what we care about is them having the same slope. So we can either get these two equations into the ax plus by equals c form, and the slope would be equal to negative a over b, or we can get them both into the y equal mx plus b form, and then our m would be the slope. Okay, so let me do y equal mx plus b. Most people are used to that, but either method would work. Our goal is to get the slopes to be equal. All right, so taking that first one, I'll have 7/5 y, and then the y on the other side, the negative 7/5 y, I'm going to add that to the other side. So move the y's to the left side, move the x's to the right side. It's going to end up being negative 3 over 11x plus 3/5. Okay, if I combine the y's, that'll be 14/5 y. Okay, equal negative 3 over 11x plus 3/5. All right, then I'll multiply both sides by 5 over 14. Give me 1y there. This will give me negative 15 over 154x. And 3 over 14. All right, if I take the second one, we already got y on the right side, so I'm going to just leave it there. So I'm going to have 5/6x plus 9/5. I'm going to subtract the 4 7s from both sides equal ky. This is going to be 5/6x plus 43 over 35. I'm going to divide everything by k. 5 over 6kx plus 43 over 35k would equal y. Okay, so again, we care about the slopes being the same. We have negative 15 over 154x. So negative 15 over 154 is the slope here. And then 5 over 6k are slope in that one. So we just set them equal to each other. And then we can just rearrange this to get k by itself. And when you have something like this, you just move things diagonally. So I'm going to move k to the top there. I'm going to move 154 to the top here. And I'll move that negative 15 down there. Okay. We multiply that out, end up getting negative 77 over 9. Okay, so that would be our correct answer. Now, how can you do this in Desmos? Let's take a look. Now in Desmos, you're probably used to putting the two equations in, you get a slider for a constant, and you play around with that to make them look parallel. Problem is, if k is not a nice integer number or 0.5 something, it's going to be hard to get it exact. You know, the negative 77 over 9 is about 8.5 repeating, so something like that. So it's good to check your answer if you want to do it that way. Okay. Now there's a different way you can do it, and you know, we only care about the slopes for these really. So what we can do here is use regression. Now we really only care about the slope, so what we're going to do is zero out the non-variable terms. So the 3/5 in the first equation, let's make that 0. The 9/5 and 4/7 in the second equation, just make those 0. Okay. We're going to get the x and y's to the same side. So we'll have 3 over 11 x1. Remember, for regression, you can't use x or y. You gotta make them x1, y1, or a different variable. Okay. So we get 3 over 11 x1 plus 7/5 y1, and then we move the other 7/5 over, you get another plus 7/5 y1. Okay, second equation, so separating by comma there, we have 5, 6 x1, move the ky to the left side, you negative ky1. Okay, and we made all our constants 0, 9/5, 0, the 4/7, 0. So then equals, basically, we use the tilde sign. Then on the right side, it's going to be just 0 on those sides. Okay, so we put that in, solves for k, gives us the decimal number. If I type in k here, I can convert it to a fraction. So there's our negative 77 over 9. Okay, so you do this by hand, like I said, making the slopes equal to each other. Okay, or you can put 0 out, and even on that one you can 0 out the constants to make it a little bit easier if you want to when doing it by hand. Okay, but for regression, you can again 0 out the constant terms, keep in the variable terms, the x and y's to both sides. In this first bracket, we put the left sides of the equation. You have to remove everything to the left, the x and y. And then comma for the second equation, the left side of that equation. Okay. And then the tilde, and then the second bracket here are going to be the right sides of the equations, which we made 0 basically. Okay. And then that makes it basically the equations equal to each other, which is really just the slope. All right, let's take a look at this system of equations. So a little bit different than the last one. We have j minus k minus 4 times the quantity m plus l equal 92. And the quantity j minus k plus 3 times the quantity m plus l equal 141. Now if you were to do this by hand, I want the j minus k to stay there, because we want, for the given system equations, what is the value of 9 times j minus k? Okay, so we can solve for j minus k. We can get the m plus l's to cancel out. Multiply that first equation by 3 to make that negative 12 times the quantity m plus l. Multiply the second equation by 4, so it'll be positive 12 m plus l. Add those two equations, the m plus l's would drop out, and then you can solve for j minus k. Okay, so we want to solve this one the fastest way possible and the most accurate way. So I'm going to try using Desmos here. Now, since we're solving for j minus k, that's really our variable, so we don't even need both of those. We can just make that x, and m plus l is kind of another variable basically. We can just make that y. So it's going to be x minus 4y equal 92, and x plus 3y equal 141. Okay, so now we just put that in Desmos. So again, you either graph it, find an intersection, or use the regression. Okay, regression gives you the more accurate answer, so you should use regression, when you can. All right, so we see here in the left bracket, we put the left sides of the equation, x1 minus 4y1, comma, x1 plus 3y1. Okay, then our tilde sign, then the right side's equation, 92, comma, 141. Okay, and we get x1 is 120 and y is 7. And we basically want 9 times x. So we can put 9x1 here, give you the value of 1080. Okay, so I made that one a lot more easier. I know a lot of problems with constants in it kind of throw people off, but you're still doing the same fundamental thing of solving a system of equations. Okay, so here we can make the j minus k just a single variable, and the m plus l a single variable. So let's take a look at this system of equations problem. It says the system of equations below has a solution xy, where x equals p over 9 and y equals q over 9. What is the value of p plus q? Okay, so in our equations themselves, we just have x and y, no constants. So we can just use decimals to see where to intersect. Again, if you graph it, depending how nice the numbers are for x and y, it might not give you the exact value, it'll round. So again, we want to try to use regression when we can. All right, so here I have the equations in there. So again, we have the left side of the equation in the first bracket, 10x1 minus 2y1, comma, then the left side of the second equation, 4x1 plus 19y1. Then our tilde separating the brackets, right bracket, the right side of the equation is 20, comma 30. Then we get x1 equal 2.2 repeating, and y1 1.1 repeating. Okay. Now we want p, x is equal to p over 9. So if you get just p, we just multiply x1 times 9. Okay, it gives us 20. Same thing with the y1, multiply that by 9. It gives 10. And then p plus q be 20 plus 10, or 30. Now another way to do this is to add those equations, the x equal p over 9 and y equal q over 9, to be part of our regression. So it solves for p and q directly. So I'm going to do here, and then a comma, x1, comma, y1. And over here, the equation was x1 equal p over 9, so we put p over 9 here. And then y1 equal q over 9, so do comma, q over 9. Okay, solves for p and q, 20 and 10. And p plus q, they give us 30. So again, we have use all those equations, the 10x minus 10y equal 20, the 4x plus 19y equal 30, the x equal p over 9, the y equal q over 9, put it all in one regression. Now solve for p and q. So I hope this video helped you understand system equations that are found on the SAT. Thanks.